So this is again a particle in a box, which is basically, it is an extension of what we just saw, 1D potential well, but this is going to be the three-dimensional case. And there is no derivation or no math here. Wherever you had an x term in the previous section, you're going to replace it with x, y, z here. That's all. So this is what we just saw. Now assume again a particle is placed in a well, but this time it has three dimensions: length, breadth, height. So we saw the expression was root 2 by L sine n pi x by L, right, for psi of x. So for psi of x, y, z, it will be root 2 by Lx sine nx pi x Lx times root 2 by Ly sine ny pi y Ly times root 2 by Lz sine nz pi z Lz. So basically for one dimension you just had the expression in terms of x. Now because it's three dimensions, you have three identical expressions, and your overall psi wave function is the product of all three. So the two important things you need to note here are, you have Lx, Ly and Lz, which represent the lengths in the three dimensions respectively. So in your 1D case, you just had 0 to L. So here, because you have three dimensions, to differentiate you are using Lx, Ly and Lz. That is one thing. And second and more important thing is, you have Nx, Ny, Nz. And they represent the quantum numbers in the respective dimensions. Quantum number can be thought of as the excitation level of the particle. For example, ground state n will be equal to 1, the first excited state n equals 2, and so on. So n represents the excitation level or the quantum number, and the quantum number can be different for each dimension. It is not necessary that because a particle is in first excited state in x direction, it is not necessary that it has to be in the first excited state in y and z also. So nx can be 1, ny can be 2, nz can be 3, anything. So you have 3 L values and 3 N values. That is the only change from one dimension to two dimension. Your wave function is a product of all the three individual wave functions, and your total energy is a sum of the energies in the three dimensions. So if you are taking a cubical box, meaning your Lx, Ly, Lz are all equal, then your quantum numbers will still be different, but the L value is the same. So it becomes root 8 by L cube, sine of this into sine of that into sine of that.